What if Terraform could stop deployment mistakes before Azure resources are even created? In this video, we are going to build a real Azure storage project using Terraform modules, implement validation, handle deployment errors properly, and upload files directly into Azure Blob Storage. Let's get started. Before we start coding with Terraform, we first need to understand Azure Storage and the different storage services available in Microsoft Azure. Azure Storage is one of the most important foundational services in Azure cloud environments. It provides durable, scalable, secure, and high performance storage for modern applications and enterprise workloads. Now let me quickly show you Azure Storage directly inside Azure Portal. Let's go to a storage account. So if I hit the create, during the creation process, Azure gives us different storage options depending on the workload requirements. You can see subscription. We can choose our subscription, also a storage account name. So here, Azure Blob Storage is commonly used for backups, files, logs, media content, and also application data. Azure Files provides managed SMB file shares, and tables and queues are commonly used for NoSQL storage and also asynchronous messaging between applications. Let's quickly look at the performance tiers that we have here. Azure provides two main options, standard and also premium. Standard storage is the most common choice and works well for backups, files, logs, and general application data. Premium storage is designed for workloads that require lower latency and higher performance. Now watch what happens when I switch between these options. You'll notice that Azure changes some of the available configuration settings. Different performance tiers support different storage capabilities and redundancy options. That's why it's important to choose the performance tier first before finalizing the storage configuration. For our Terraform demo, we'll use the standard storage because it's simple, cost effective, and commonly used in learning environments. Let's talk about redundancy. Redundancy determines how Azure protects your data. LRS, or locally redundant storage, keeps multiple copies of your data within the same data center. It's the lowest cost option and great for lab environments. GRS, or geo-redundant storage, replicates your data to a secondary Azure region for additional protection and disaster recovery. Let's go and create a storage account. I'm gonna pick a name for it. Video part 9, and then choose Azure Blob Storage. Review and create. So after deployment, we can go open the storage account, and also we can go through the containers. Blob containers are used to store files, logs, backups, scripts, and application data. In our Terraform project later, we are going to automatically create a blob container and upload a file into Azure file. In our Terraform project later, we are going to automatically create a blob container and upload a file into Azure Storage. And we can also manually create blob containers directly inside Azure Storage, but later Terraform will automate this entire process for us. Let's talk about what can we store. Azure Storage supports multiple storage services depending on the workload requirements. Blob storage is used for unstructured data such as images, videos, backups, logs, and documents. Azure Files provides managed cloud file shares. Table storage is designed for large scale NoSQL data. And queue storage helps applications communicate asynchronously. And this is how it works: sending data by application, authenticating and authorizing by Azure Storage. Also, data is stored, and then data is accessible anytime, anywhere, and highly available. Azure Storage is heavily used in real world enterprise environments. Companies use it for backups and disaster recovery, media streaming, analytics and data lakes, aesthetics, website hosting, and IoT workloads, and also for long term archiving storage. As I mentioned before, we are going to understand two very important concepts: validation and error handling. Validation helps us verify user inputs before deployment starts. Instead of allowing invalid values to reach Azure and fail later, Terraform can stop the deployment early and display a clear message. Good error handling is not only about stopping failures, it's also about making deployments easier to troubleshoot and understand. We want clear error messages, user friendly feedback, graceful recovery whenever possible, and proper logging and monitoring. Now let's apply these concepts to a real Terraform scenario. In this project, we'll create a resource group, a storage account, a blob container, and upload a verification file into Azure Storage using Terraform modules. In this Terraform code, the company only allows deployments in approved Azure regions. So we will use Terraform validation to verify the location before deployment begins. If someone enters an invalid region, Terraform immediately stops and shows a custom error message. We are at VS Code. Let's implement the scenario step by step. In this lab, the root Terraform files will control the main deployment, and the storage module will handle the storage account, blob container, and file upload. We start from the root main.tf. This file is the entry point of the project. First, we create resource group. Notice that the location is not hard-coded. It comes from var.location. This is important because we want to validate the location before Terraform creates anything. Here we are calling the storage module. We use a module because a storage account creation can be reused in other projects. Instead of writing the same storage account code again and again, we put it inside a module and pass values into it. The terraform.tfvars file is where we provide values. In this scenario, the user chooses the Azure region here. The user also defines which local file Terraform should upload it to Azure Blob Storage. And this is the value we are going to validate in our Terraform code. Let's move to variables.tf. This is the validation block. The company only allows deployments in approved regions. So we use Terraform validation to check whether the region is allowed. The contains function checks if valid location exists in our approved list. If it does, Terraform continues. If it doesn't, Terraform stops immediately and shows our custom error message. Inside the Azure Storage module, the first resource is the storage account. This is where Azure Blob Storage lives. We use a standard because it's cost effective and common for lab environment. And we use LRS because it is simple and cheapest redundancy option. After the storage account is created, we create a blob container. A container is like a folder inside blob storage. We need a container before we can upload files. We set it to provide because that is the safest default. Finally, we upload a file using Azure RMS storage underline blob. This makes the demo more realistic because we are not only creating an empty container. Terraform takes a local file from my machine and uploads it into Azure Blob Storage. So let's move to Terraform the two first. Now I intentionally changed the region to West US. This region is not in our approved list. When I run Terraform plan, Terraform should stop before deployment. Let's run it and check the result. Terraform, let me save this as well first. So Terraform it. Okay, Terraform plan. Most probably it's going to show the error about the region because West US is not in approved list. Look at this. On Terraform, look at the West US. Invalid location, allow regions, Canada Central, East US, and West Europe. I'm going to use Canada Central. Okay. Perfect. Terraform blocked the deployment. This proves our validation and error handling are working. The validation rule caught the mistake and the customer message explained the problem. So it's going to create a storage account on all of those things. And I'll show you the result after that. Let's do Terraform apply. And as always, you can find the complete code on my GitHub repository. The link is available in the description below. So our resources were curated. Let's go and verify it on Azure portal. Let's move to VS Code and see what do we have in hello.txt. I forgot to show you. This is what we have here. Hello from Terraform part 9. This file was uploaded to Azure Blob Storage using Terraform. Okay. Let's go back to Azure portal. So if I click on it and download it, okay, I'm gonna show you what do we have here. At this point, we've successfully completed the entire scenario from start to finish. We started by understanding Azure Storage and different storage options available. We then built a reusable Terraform Azure to create an Azure Storage account, a blob container, and upload a file automatically. Along the way, we implemented validation to control which Azure regions are allowed for deployment. We also tested our error handling by intentionally using invalid region and verifying that Terraform stopped the deployment before creating any resources. So, and now that we have working storage account deployment, we're ready to take things a step further. In part 10, we learn how to use Terraform's file function to read external files directly into our Terraform code. We'll also introduce Azure endpoints and start exploring how Azure services can be accessed securely in enterprise environments. These concepts are commonly used when deploying applications, automating configurations, and building more secure cloud environments. Thank you for watching.